What's up guys, welcome back to the channel. Today in this video we'll be solving this previous question paper that you see here. So this is a national certificate mathematics N4. So this question paper here, it was actually written on the 22nd November 2003. Is an X paper which it was actually written at 9 o'clock to 12 o'clock. So usually it takes 3 hours for this type of question paper, and it consists of 100 marks. So the entire question paper has 100 marks, and it has 5 questions in most cases. So guys, I'm gonna do all the questions, and you will choose which question you are interested to watch. Remember, there will be a timestamp on this video, so if you don't want to watch question 1, for example, you can click on the timestamp of the question that you're interested. Let's say, for example, you are interested in question 4. You don't really have to watch the entire question paper for whatever the reason. Maybe you don't have time to watch the maybe question 2. But if you are interested to watch the entire question paper, you can just watch the question paper in a sequence order. All right, so we're gonna start with question 1, and then from there we continue and do other questions. All right, guys. So this is question 1. As you can see, the first question here, which is question 1.1.1, they want you to draw a graph here. So first of all, you need to know what this graph is. So what I'm going to do here, I'm just gonna copy this question and put it on the side, and then we start solving it. So let me just do the copying and let's start solving. All right, so this is actually the question from the question 1. So this is 1.1.1. So they want you to draw this graph. Guys, before you draw this graph, you need to understand what type of a graph is this. So from the first thing that I know about graph is I look at our variables here. We have x squared and y squared, and this is equaling to 1. Now look guys, this is actually an ellipse. So if you don't know what an ellipse is, it's supposed to be a graph that has a shape like this or a shape like that, right? So it's more like a circle, but not really, more like a American football shape. So it's supposed to look like this, or a rugby football shape. Okay, so this is how it looks like, right? So there is a general formula for this type of graph. So let me first write the general formula so that I can explain it from there. So we have x squared over a squared, right, plus y squared over b squared. There we go. And this is equaling to 1. So this is actually the general formula for the ellipse. So all you need to know guys is that a is an intercept of x, and b is an intercept of y. So it's supposed to be equaling to 1. So as you can see, the one that is given to us here, it still has the coefficient of x and y. So you need to get rid of this coefficient of x and y in order for us to draw this graph. What's so nice about this is that we can actually simplify this. So we can say 4 divided by 4, we're going to be left with x squared. But then on the denominator, we can say 100 divided by 4 is going to give us 25, right? Plus, now we go to the next step, which is 25y squared over 100. So 25 divided by 25, we have 1 multiplied by y squared. 100 divided by 25, this is going to give us 4, right? So this is equaling to 1. As you can see now, look at the general formula. We have x squared divided by a squared. So meaning here, our a squared, x squared divided by 25 is going to be 25, right? So we need to solve for a. So we are not looking for a squared, we are looking for a. So a is gonna be square rooted. So we square root a, we're gonna have a, and then what is the square root of 25? Is plus or minus 5. So for a we are fine, we managed to get it. What about b? Now we are looking for this b. So we know that b squared here, what is dividing y squared, is usually 4. So in order for us to get actual b, we must square root this, right? So when you square root b here, it's going to be plus or minus, what is the square root of 4? Is going to be 2, right? So basically this is our intercept. So we know that a is an intercept of x and then b is an intercept of y. Just in case you don't know or you can't remember this, it's very simple. Once you know the general formula, just know that a is dividing x, so it's going to be the intercept of x. B, which is dividing y, is going to be the intercept of y. So now we know that at x we're going to intersect at plus or minus 5, at y we're going to intersect at plus or minus 2. So let's draw it here. It's time for us to draw a graph. So when you draw your graph, guys, do not forget to do the dots here. All you have to do is do the dots and then you start connecting. All right, so it's time for us to connect. So I'm gonna try to connect. It might not look exactly like the ones that you see there, but as long as it is intercepting on the right values there, okay, even though it doesn't look good, let's stick to the one that we drew here. But as you can see, it looks like the one here on our left. So basically this is the correct answer, as long as you show your intercept, your y-intercept, your x-intercept, and also you get the values for those intercepts. So this is out of 3 marks. I hope this was not that difficult for you guys. Just in case you didn't know how to draw this graph, this is how you draw it, guys. Okay, how do you know this is an ellipse? Whenever there is a plus here and then it's equaling to 1, just know that this is an ellipse. Okay, they can trick you, but this one basically it's straightforward. You didn't need much to simplify. All right, guys, we are done with question 1.1. It's time for us to do question 1.1.2. All right, guys, before we do question 1.1.2, so by the way, this is question 1.1.2. Let me just highlight it for you guys. Let me just highlight very quickly. This is the one here, right? This is question 1.1.2. But before we do it, I would like to say don't forget to subscribe to the channel. Also, don't forget to share this video with your friends. So I'm gonna copy this question again because they want us to draw again a graph. Okay, guys, so I already copied this question. So they want you to draw the graph that you see here, guys. Look, if you look at this graph, it kind of looks similar to the one that we just did before this, but it's really not the same. So how do you identify these graphs here? When you look at this one, these two terms are separated by a negative sign there, while the other one, the two terms were separated by a positive sign. So be very careful, be very careful. So when I look at this graph, this is actually a central hyperbola, right? So we have two types of central hyperbola. So let me show you the general formulas for central hyperbola before we continue. Again, I'm going to show you how do they look like. So I'm going to write those general formulas in. So we have a general formula for this one where we have x squared over a squared minus, notice there is a negative here, and then we have y squared over b squared. All this is equaling to 1. So how do you know how does it look like? So this is how it's supposed to look like. This one, let me just write very quickly because in general it's supposed to look like this one. X and y, it's supposed to look like this. Since our x is positive, it's supposed to intersect at x, like this, right? And like that, right? Then there is a line that's supposed to, there are two lines that's supposed to cross here from the origin going that way. So I'm gonna try not to ruin this. There are two lines that are supposed to go there. I'm gonna explain this later, but basically this graph that you see here is supposed to look like this. I hope you guys can see this, right? And then we have another one where we have y is negative, is positive. So another one, it looks like this. They're still all central hyperbola, by the way. So we have this one, we have y squared minus x squared, but then they are also divided by the same a and b there. Y is divided by b squared, and and then the x is divided by a squared. So it's also similar. So this is also a central hyperbola, guys. As you can see, what separates these two terms, it's the negative sign. Once there's a positive sign, it's no longer a central hyperbola, it's actually an ellipse. So you have to be very, very careful because they look very similar, guys, right? So how does this one look like? I'm just going to try to draw it here. Since y is positive here, this one here is going to look like that. It's going to intersect at y. So let me first draw my lines here, the line that are going straight like that, and the line that are going straight like this, right? There are two lines that actually this graph must asymptote at, right? But these lines, they are also passing at origin. Hopefully I'm going to try to explain them way much better. So this graph here, since y is positive, it's going to intercept at y, and it's going to look like that, right? There we go, asymptote line, and it looks like that. The asymptote to this side, and then there we go. I hope you can see, guys. I hope you can actually see. It's trying to make a straight line. You don't want to make a straight line, you just make it curvy, right? So this is how it looks like. As you can see, we have two different graphs here. They are actually both central hyperbolas, but this one here, let's start with this one. When it intersects at x, it means that our x is positive. When it intersects at y, it means our y is positive. Be very, very careful. Again, when you see negative between these two, just know that it's a central hyperbola. So let's look at the one that is given to us here. All right, so look at this. We have 4x squared divided by 36. So if we simplify this one, I'm just going to do it here at the corner. We're just going to have x squared over, because if we say 4 divided by 4, we're going to have 1 multiplied by x squared. We're fine. What are we going to have there? We're going to have 9. There we go. We're going to have 9 minus, right? All right, so let's look at y there. So if you say 9 divided by 9, it's going to be 1 multiplied by y squared. That is going to be y squared divided by, what is 36 divided by 9? It's going to give us 4. And this is equaling to 1. Right. So basically, that's how you solve this one. That's how you simplify this one. Again, do not forget, look, same as our ellipse, we are dividing, x is divided by a squared and y squared is divided by b squared. So do not forget that. So meaning here, our a squared is equaling to 9. Now if you're looking for a, we have to square root both a squared and 9. So the answer is going to be plus or minus 3. Right. So let's look for b. Remember, b is the one that is dividing y. So b squared is the same as 4. So when we're looking for b, we have to square root these two. So our b here is going to be plus or minus 2. Right. So basically, these are the ones that we have here. So since we know this is gonna intercept at x, so we know that this our graph is gonna look like this, meaning this part here is gonna be x. But then how do we get these lines here, the lines that are actually our graph asymptoting at? How do we get them? There is a formula. It goes like this: y is equaling to plus or minus b over a multiplied by x. So basically when you substitute this is the same as plus or minus b. What is your b? Is going to be 2 over 3 then x. If you look at this graph here, these are actually straight line graph, guys. These are straight line graph. If you know your straight line graph, as long as we don't have c, remember our c is 0 here, as long as we don't have c, our graph is gonna pass at origin, just like these red lines here that you see here. I hope you can see them though. I hope you can see them. So I'm just gonna erase this and create space for us here. So you're gonna write your Cartesian plane. I'm gonna try to make it bigger, this one, because I want you guys to see what we are doing here. All right, so we have the 0 point here, we have the x-axis and the y-axis. Make sure that you show the axis as well. Then from here, look, this graph here, we have the one that is positive. So the one that is positive, let me just do this. I just want to make it to be dotted line. Let me just try to be as accurate as I can be, guys. Okay, so it's passing at the 0 point there. So this one here, we can say this graph here, we can say this graph here is equaling to y is equaling to, if it's like this, the gradient is positive, it's equaling to 2 over 3x, right? And then the other one that is gonna go this way, let me try to make it that way. Guys, you can try to use the table to draw this graph, but look at the marks. The marks are so low, there's no need for you to do that, guys, right? So this one here, the graph is actually negative, is equal to negative 2 over 3x, because when the gradient is negative, the graph is going to lean this way. When it's positive, it's going to lean that way, right? So now look, what do we say at the beginning of this question? We said that if x is positive, it's going to intercept at x. So where exactly, what is the point at which this graph is intersecting? So this graph is going to intersect here at 3. Okay, let me just change the color here so that you guys can be able to see. As you can see, it's positive 3 and negative 3. So let me try to put it here. Let's just say this is negative 3 and that one is positive 3. So our graph is gonna intersect here, right? So these lines here, we call them the asymptote lines. Okay, they are straight line graphs, but they are asymptote line, and they always passing at the origin, guys. Okay, they're always passing at the origin. So how do you do it? So this is how you draw your graph, guys. Hopefully you're gonna be able to see it. Okay, as you can see, this graph of yours, it shall not pass this asymptote line. It should asymptote on this line. Never ever pass these lines. Okay, even this side here, the graph is supposed to look like that. Okay, even this side here is supposed to asymptote here. Never ever, guys, don't ever cut this asymptote line, because that's where they will see that you don't know what you're doing. Okay, so as you can see, this is our this graph. Look at this graph. This graph now, central hyperbola that is given to us. It looks like this is for this central hyperbola that is given to us here. I hope, guys, this makes sense. I hope you guys understand, because if you don't understand what's so nice about this, you can always watch this video over and over again. I know it takes time, but I needed to explain this because some people they confuse this formula and they think it's an ellipse or a circle. It's not a circle, it also is not an ellipse. So guys, I hope you understand. If you don't understand, rewatch this video, and also you can ask questions wherever you think you don't understand. Right, it's time for us to do the next question. So before we do that next question, do not forget to subscribe and also share this video. Like this video as if this helps to understand better. All right, we are done with 1.1. Now it's time for us to do 1.2. Now 1.2 is actually word problem. We are done with graphs. Now it's time for us to do the word problem. So we need to find the value of the new length and width after the area is being doubled. So we're gonna read the statement here that you see here. So this is question 1.2. So again, I'm just gonna copy this question and paste it somewhere else so that we can focus on it. But this is 1.2. Right, so this is the question that we have here. So what is it that they want us to do here? Let's read this question very quickly. They say a rectangular piece of sheet metal is 10 meters long and 5 meters wide. If the area doubles when the length and the width is increased by the same unit of the length, what are the new measurements? So basically they want to know what is the new length, what is the new width when the area doubles. So that's basically what do they ask for. But we are also given another information that we need to pay attention. They said here when the length and the width is increased by the same unit. So it means that the length and the width, they're gonna increase by the same unit length. All right, let me just draw it here, guys. So the 10 meter, it's under the length, right? So how long from here to there? It's 10 meters, right? And then the width from here to there, it's actually 5 meters. They say the area doubles now. So the area, let's make it bigger this time. The area doubles, okay? The area doubles. Basically, this is what is happening. The area doubles, right? There we go. So if this one has an area of 50 meters squared, then this one is supposed to have an area of 100, because 50 multiplied by 2, this is going to give us 100 meters cubed, because the area double. That's what they said here. Where is it? Let me highlight it very quickly. So the area doubles here. You guys see? So the area doubles, right? But then they said again, if you continue here, they did mention that the width, the length, and the width is increased by the same unit of length. So we can say that same unit of length, we can say it's x. We don't know what it is, so we are looking for it. We can say it's x plus 10 because it increased by that meters, right? It increased by the same length. And then the width, we can say it's x plus 5 meters. You guys see? So we can say that because they say it increased by the same length. I cannot stress enough about this because we need to understand this one. It was a bit tricky, but if you pay attention, this is basically how you do it. So all right, so let's try to solve this one. So we know the formula of an area. The formula of an area is equaling to length multiplied by the width in this case, right? Let's start here. What is our area? Our area is 100 when it's double, guys, right? And then what is our length? our length is x plus 10. Right, what is our width? Our width is x plus 5. There we go. So from here we have to do the foil here. So we have 100, right? X multiplied by x, we have x squared, and then we can say x multiplied by 5 with plus 5x, x multiplied by 10 with plus 10x, and 10 multiplied by 5 we have 15. Right, we have 15. So from here we continue, we write x squared and plus, these are like terms, so what is 5 plus 10 is going to be 15x plus 5. Very simple. Then what we do, we take this 100 to the other side, we left with 0. This is going to be x squared plus 15, and then we have plus 50 minus 100. Right, so this is going to be the final answer. Our final answer is going to be x squared, oh I forgot x here, x squared 15x, what is 50 minus 100? It's going to be minus 50. So from here we need to simplify this one here. Okay, so let's try to simplify. So in fact we need to solve for x here, which is the same value that we are looking for here. So in order for us to solve for this x, let me just create a space here. We need to use, by the way, we need to use the quadratic formula, factorize this. So use the quadratic formula. So the quadratic formula, we all know it goes like this: x is equal to negative b plus or minus b squared minus 4ac divided by 2a. Right, so from here what do? We just substitute. Remember, this is from this equation here, the quadratic formula. We know that a is a coefficient of x squared, and then b is a coefficient of x, and c is the constant. Right, is the constant. So you look at this and see whether they correspond. So let's substitute here. What is our b here? When you look at our b, is a coefficient of x, it's going to be 15, so it's going to be negative 15. There we go. Plus or minus, right? So what is our b again? Unfortunately it's still 15, unfortunately, right? Minus 4. Then what is our a? Is a coefficient of x squared, which is 1. And then what is our c? It's a constant here, which is negative 15. Negative 15. Okay, there we go. Even though it doesn't look so good, but that's negative 50 divided by, what is our a again? The coefficient of x squared, it's 1. Now there's something that I need to explain here. You see this plus or minus, basically this means or. So when you put this on a calculator, this is how you're gonna put it. So I'm gonna try to put it in that manner. So this is positive, or when it's negative, right? So each and every one of these, they're gonna give us the answer. So the answer for this one is gonna give us 2,80 meters. Okay, guys, don't forget that whenever you write your answer, leave it into 3 decimal points, guys. So since we are dealing with a distance, we don't have a negative distance here, guys, right? So we scrap this one here. We scrap the one with the negative answer. So this one here, it's invalid. So this one, it's not applicable, guys. Right? So you leave this one here, not applicable. So meaning we have to take this 2,808 and then we substitute it on our formulas. All right, let's get our length and our width when it's double. So let's continue. So we know that this is a formula for length. Let me just go this way. All right, yes, this is a formula for length, and this is the formula for width. So we know that length, let me just write it here, length is gonna be there we go. Remember, they want us to get those length after the area is double. So this is the length here, and then for the width is x plus 5. So these are the final answers, guys, the width and the length when the area is doubled. So I hope you guys managed to see this one. It was a bit long, but really it was not that difficult. All right, guys, so this was 1.2. We are done with 1.2. If it so happened that you understood 1.2, don't forget to like the video, subscribe to the channel if you haven't subscribed, and also share this video to your friends. Now let's go and do the next question. Right, guys, so let's do question 1.3. So here's question 1.3. Now this question here, they just want you to make x subject of the formula. So here's the formula that they want you guys to solve here, or to manipulate. So I'm gonna copy this question and then I'm gonna put it aside so that we can able to solve this question, so that we can have space. Right, guys, so I already copied this formula. So what they want here, guys, they want us to make x subject to the formula. So how are you gonna do this one, guys? So the first thing that you must do here is to try to get rid of fraction. As you can see, we have t is equaling to e to the power of 2x plus 1 divided by e to the power of 2x minus 1. So get rid of this fraction. So what you can do is cross multiplication. So you can say t, let me just do it very quickly. You can say t multiplied by underneath the denominator on the right hand side. So you cross multiply here, it's going to be e to the power of 2x minus 1. You have to know that t is divided by 1, so we also do the cross multiplication, which is going to be the same as the numerator on the right hand side, plus 1. So it's going to be e to the power of 2x plus 1. So this is actually how you do it. From there you get rid of the brackets. So let's get rid of the brackets. So the first term is going to be t multiplied by e to the power of 2x, and then t multiplied by 1 is going to be t, and this one here, there's nothing we can do at the moment. Just write it as it is on the right hand side. So from here, what you can do is you take this t, you transpose it to the right hand side, and you're going to take this e to the power of 2x, you transpose it to the left hand side. So let's do it. So let's start with this t. So we're going to have t, right, and then we have e to the power of 2x, and then we transpose this e to the power of 2x to the left hand side. So it's going to change the sign. It's going to be negative e to the power of 2x, then is equal to, so we also transpose this t to the right hand side. It's going to be 1, or it's going to be positive t, in fact, since it was negative, plus 1. So this is basically how it looks like. Then on your left hand side, as you can see, you have two terms here, and they both have e to the power of 2x. So you're going to take out the common factor. Let's take out our common factor, which is e to the power of 2x. So the first term here is going to be left with t minus 1, because the second term is going to be left with 1. And then we have t plus 1 on our right hand side. Right, so from here, what do? We divide by this t minus 1. So we're going to be left with e to the power of 2x. And then when we divide by t minus 1 on our right hand side, we're going to be left with t minus 1, because we divided by t minus 1 both sides. And then this, they're going to give you 1. All right, so this is what we have. So from here, guys, it's time for us to introduce the natural log. The best way here, just introduce the natural log. So when you introduce the natural log, you have to introduce it for both sides. There is a rule, let me just write it here very quickly, that goes like this. When you have natural log, let's say x to the power of 2 is the same as 2 natural log x. This exponent, it comes to the front. Do not forget that. So we're going to use this rule here on our left hand side. So we're going to take this 2x to the front. So it's going to be 2x, right, is equaling to 2x multiplied by natural log e, right? And then on this right hand side, we just leave it as it is. We don't do anything at the moment. So natural log t plus 1 and t minus 1. All right, I hope you guys can see what's happening here. Now there's another thing that you need to know. Natural log e is the same as 1. So here we can just say this is 1. So if we rewrite this, it's going to be x. Then we continue, leave it the right hand side, we leave it as it is, because we cannot do anything at the moment, right? I know this takes longer, but step by step, so that everyone can understand. So from here, what do? We divide by 2 both sides. Remember, we're looking for x. We divide by 2 both sides. So when you divide by 2, here we're going to be left with x, right? And then we're going to have you can write it like this if you want to: 1 over 2 multiplied by natural log, and then we say t plus 1, and then t minus 1. All right, so this, you can leave it like this. I think the answer is correct like that, but you can still continue using the rule that I showed you here, guys. You see this rule? You can reverse. You can take it from here going this way. We have half, so if you take half to the other side, so we're gonna have something like this: natural log, and then we have t plus 1 over t minus 1 to the power of half, right? To the power of half. So this here, let me just put it here. This here, you can write it as x is equaling to natural log. What is power of half? If we say x to the power of half is the same as square root x. So we can do the same thing. We say square root, we leave it in a sad form. It's gonna be t plus 1 divided by t minus 1. So this here, guys, is our final answer. But I think you can also leave it here. I don't think they will have a problem with you guys. So that's basically how you do this one. I hope you managed to understand this one. If it so happen that you didn't understand anyway, you can pause this video, go back, and let's see if you can detect where you get lost. But if you manage to understand this one, don't forget to subscribe and share this video to your friends. All right, guys, let's do the last question of question 1, and then we are finished with question 1. Right, so this is the last question for question 1. which is question 4.1. So here they just want you to solve for x. I don't think this is difficult, but just in case you find it difficult, let's solve this one. Let's try to be quick on this one. Right, so I'm gonna copy this question here, and then we're gonna solve it on the side. All right, so let me copy this question and let's solve it. Right, guys, so let's do this one. 4.1.4, I mean. This blue thing here basically means the question is challenging, but I don't find this one to be challenging. All you need to know is that you need to use a calculator. But anyway, let's just do this one. So as you can see, you have 12 to the power of x plus 1 is equaling to 36. So we are solving for x here. So first thing first, you need to understand that this 12 to the power of x plus 1, you can actually use the exponent rules in order for you to solve this one. There are many ways of solving this one. I'd rather go with this way, okay? So you can use the exponent rule. You know that, let me just explain the rule that I'm talking about. If you have a to the power of n plus m, this is the same as a, right, n multiplied by a to the power of m, right? So you can separate this like that. It means the base they are multiplying, the exponent are adding. So let me rewrite it here. I can say 12, right, to the power of x multiplied by 12 to the power of 1. Even if you don't write it, it's fine, this one here, and then the answer is 36, or this is equaling to 36. So from here you can divide by 12. So let's divide by 12, dividing by 12, dividing by 12, even this side. So if I divide by 12 here, 12 and 12, they're going to give us 1. So we left with 12 to the power of x, and here 36 divided by 12, we left with 3, right? So from here, guys, there's nothing we can do. We also need to just introduce natural log. So let's introduce our natural log here. So let's introduce it. So introduce natural log on this right hand side. You have 12 to the power of x, and then we have natural log here, then 3, right? Again, if you didn't watch the previous question, which was question 1.3, I did explain the rule here. There is another rule for natural log, which is similar to logs, by the way, where you have something like this, natural log, then we have x to the power of, let's say, a. We can say a is equaling to natural log x, where we take this exponent to the front. So that's what we did here. So we can do the very same thing here. We can say x, the natural log 12, and then this is equaling to natural log 3, right? So from here, what do? We divide by natural log 12. So this is gonna be x was that, and that it's 1. But this one here, you rather use your calculator, guys. So if you use your calculator, put this in your calculator, it's gonna be 0.442. So that is your final answer. Like I said, this was not much of a challenge. You just needed to know your exponent and your logs at some point. All right, guys, so this is the rest of question 1. I hope you guys managed to understand it. I hope you managed to get the total marks for question 1. I'm hoping that you guys are sharing this information and also subscribing to the channel, because I'm going to do question 2 after here. Thank you very much, guys, for watching. Do not forget to like and subscribe, comment as well, and share these videos to your friends. And also, guys, at the end of this video, if you want to watch question 2, go to the playlist. You will see this question paper. I will have question 1 to question 5. At the end of this video, the playlist is also gonna appear. Thank you very much, guys, for watching. Till next time, cheers.